Hi, today I'll be talking about JavaScript ES6 iterators and generators. Iterators and generators are actually one of my favorite parts of JavaScript ES6, and hopefully by the end of this talk you'll see why that is. Iterators and generators constitute a mechanism for iterating or enumerating collections and sequences, which is why we have this snake going around in a circle. As you can see, the symbol that the snake is actually tracing is the symbol for infinity, and as we will see later in this talk, you can actually use iterators to enumerate portions of infinite sequences, which is actually useful. And we will see how that works. We will also do a little bit of live coding in this session, which is always fun. In talking about iterators and generators, we'll be touching on three main questions, or three W's. We'll be talking about why iterators and generators are actually so useful in the context of ES6. We'll be talking about how they're actually implemented. And finally, we'll be talking about the what. What are they useful for? And when you should be using them. First, though, a few words about myself. So I'm Dan Shappir. I'm a performance specialist at Wix. Wix, for those of you who don't know, is a company that provides a cloud platform for easily building beautiful, wonderful websites. My role at Wix is to help those websites load faster and execute faster, which is a big challenge and really important given that we have over 70 million websites hosted on our platform. I also tweet quite a lot, especially about technical topics, stuff like JavaScript, like ES6, and things having to do with performance and whatnot. And I also occasionally post on the Wix engineering blog, which has a lot of very useful and highly recommended content. I do recommend that you visit it and read some of the articles that you'll find there. Okay, enough about myself. Back to the topic. Iterators and generators. You know, they are part of ES6, and ES6's official name is actually ES2015. And given that it's now 2015, it does mean that we should start using some of these features and capabilities. And in fact, we can. If we look at the current versions of Chrome, Firefox, and even Microsoft Edge, we will see that they already support both iterators and generators, and in fact have been supporting them for quite a while. In the case of Microsoft Edge, you do have to enable a certain experimental flag to get generators, but iterators at least are implemented right out of the box. You can also use iterators and generators with Node. The latest version of Node has both, but again, getting generators does require command line switch, the -- harmony command line flag. If you're using IO.js, you can actually get them both right out of the box, and since they are apparently finally converging again, I do hope that we will have both iterators and generators working right out of the box in both Node and IO.js. In case you do need to support some older, or let's say more primitive environments, I don't know, Microsoft Internet Explorer, whatever, you can also use a transpiling tool or compiling tool to transpile ES6 into an older version of JavaScript. There's Traceur, and my personal favorite, which is Babel. You just input the ES6 code into them, and you get ES5 standard code out, which will work on any browser out there. And if you're into TypeScript, I know some of you probably are, then TypeScript version 1.5 does have iterator support built in, and the upcoming version 1.6, which is I think currently in beta, actually has support for generators as well. So that answers the when before we can get to the other questions. Let's talk a little bit about the purpose of ES6 itself, and then we can see how both iterators and generators fit into that. So the purpose of ES6 is not to enable us to do stuff that we couldn't do before. It's more about making the JavaScript development be a more pleasant and useful and worthwhile practice. So ES6 is more pleasant to write, it's easier to read, and consequently, it's less bug prone. Because if our code is easier to write and we write fewer lines of code, then generally we will have fewer bugs. So that's really the purpose of ES6. Now, if we look at that goal of making JavaScript more expressive, then it ties back into two very significant features in programming languages, which are collections and algorithms. They are really significant cornerstones of expressiveness in modern programming languages. Collections are objects that store other objects, allowing both access, and that means both inserting new objects into them or retrieving objects out of them, and also traversal, which is the possibility of going over the various elements or objects stored within them one after the other. And algorithms are canned and reusable operations that can often be applied to collections. Can anybody here think maybe of a particular algorithm that can be implemented on top of a collection? Well, one possibility might be to find the average of a collection of numbers, or the median, or the maximum, or the minimum, or the sum. All of these are algorithms. Other algorithms including search, filtering, and so forth. So when we look at the current state of ES5, that is JavaScript prior to ES6, what type of collections do we have? Well, we find that we don't have a lot of collections, but we do have a couple. First and foremost, they're arrays. Arrays, in fact, in JavaScript are so flexible that they often provide functionality that other programming languages provide in several collections instead of just the one. You can use them as arrays. You can also use them as stacks. You can use them as queues. Additionally, we have regular JavaScript object, which in a way that's really strange to people coming from other programming languages, actually also function as dictionaries, which means that we can use them to store key value pairs. We can have a certain key value, a certain value, and then we associate them together in a dictionary using a regular object. Strings are kind of collections. They're collections of characters, you can say, but people don't really use them that way most of the time, and they're also invariant, so they're not really what you think about when you think about collections. And finally, we do have some pseudo-arrays in JavaScript. Can anybody think of an example of a pseudo-array in JavaScript? Well, one example would be, for example, the arguments pseudo-array. The arguments object in JavaScript looks like an array. It has the index of operator, the square brackets, but is in fact not really an array, and we will see some of these limitations later on. There are also typed arrays. There are node lists. Node lists are objects that are returned by some DOM functions that return a list of nodes. For example, query selector all would return a node list, which kind of, again, looks like an array, but isn't quite an array. So ES5 also has a couple of algorithms. But the thing is, they're kind of tied to specific collections. And in fact, most of them are just on top of arrays. So for arrays, we do actually have a large number of algorithms built into JavaScript. We have for each, which just lets us iterate over a collection. We have map, which allows us to transform one array into another, filter to get certain elements, reduce, sort, and so forth. So for arrays, as I said, we do actually have quite a number of algorithms, even in ES5. However, for other things, the situation is much more limited. For example, for pseudo-arrays, what we actually have to do is essentially transform them into array, and the common way of doing that is to use array prototype slice call, just to transform or copy effectively the pseudo-array into an array, just so that we can apply all of these array algorithms to that pseudo-array. And that kind of makes it annoying that we have something that we can't really use the way in which you would want to use it. We need to transform it into something else with additional overhead and everything else that's associated with it. For objects, well, objects don't really have algorithms so much at all, which as a result pushes us towards using third-party libraries, usually Lodash or Underscore. So Lodash and Underscore are both libraries that are very popular precisely because they provide a significant number of algorithms on top of objects when these objects are used as dictionaries. Alternatively, we can use object keys to transform the object effectively into an array of keys and then use that array as a means to traverse and do operations on top of the object. Again, not a very comfortable or useful approach. Now, the result of this limitation, of the fact that we don't have general purpose algorithms in ES5, and instead they are tied to specific collection types, is that people generally don't implement their own collections when they develop in JavaScript. They just use arrays, again, because arrays have all of these algorithms built in. And just to show why that is, I've actually implemented a very simple list collection, and I'll show the limitations of using that collection in the sense that it doesn't really have algorithms that support it. And let's look at this example. So this is a very simple implementation of a linked list. Linked list, for those of you who may not remember, is a list of values where you have container objects that contain the actual value, and each one of them contains a reference to the next element in the list. So you see here the linked list type object really has just two methods in this case. I made it very simple. Add, which receives a value and basically adds it at the end of the existing linked list. And for each, which is an algorithm for iterating on over all the items in the linked list, over that entire collection. So you see, because I can't use the existing for each algorithm, I actually needed to implement it myself. And as a result, if I want other algorithms like filter or map or whatever, again, I would need to implement them myself. I can't use the ones that already exist on top of array. The alternative, of course, would be to copy the linked list into an array, but that kind of defeats the whole purpose of having that additional distinct collection type. Let's see how I actually use this collection type. By the way, notice that the add method returns this, which means that I can actually string or chain a couple of add calls one after the other, just to make it a little bit easier to use. So let's see how that works. Let's open the development environment and go into the console. I'll make it a bigger so it's easier to read. So let's first create a new instance of a linked list. And now I can add some values into it. So let's say I add 3 values. And finally, just so that it won't be too sequential. And now, if I want to iterate over these items, I would do something like this. So nice to be able to use the arrow syntax for defining functions. And here, I've iterated over the list. So again, I have the for each algorithm, which allows me to iterate over the elements, but that's it. If I want to map, I can't. I need to either implement it myself, manually copy into an array or something like that. Very limiting. And as a result, as I said before, a lot of people just don't implement their own collection types in JavaScript precisely for that reason. The solution for this problem of not having algorithms for all the collection types which I have is in the form of an iterator. An iterator is actually a design pattern. For those of you who've read the Gang of Four, I've used the Fantastic Four image here, but it's actually the Gang of Four. For those of you who've read their book on design pattern, they introduce an iterator design pattern. And the whole idea is to abstract the relationship between a container and the algorithms that you apply on top of it. So an iterator really provides an access to aggregate or collect objects or collections sequentially without exposing its underlying implementation or representation. That means you can use the same interface, the same iterator interface, to iterate over elements in whatever type of a collection. And therefore, you can, if you implement your algorithm on top of that iterator interface, you really don't care how the collection is implemented internally. So effectively, as is stated below, iterators decouple algorithms and collections. Let's look at a very simple way in which ES6 actually implements or defines or specifies iterators. They are simply methods that return an object. So here I have an iterator factory on a collection. That means I have a method which returns new instances of iterators. That's why it is a factory. So every time I call the function, the iterator factory function, I get a new iterator instance. And as you can see, that iterator is just an object. And that object, all it really needs to have is a next method or next function associated with it. Now, can anybody guess why I put up the image of a duck? The answer is duck typing. In most other programming languages that have similar capabilities or features, you, in order to implement an iterator, usually need to implement a certain interface or extend or derive from a certain object. That's not the case in JavaScript. In JavaScript, in order to be an iterator, you simply need to look like an iterator, which means that you can be any object that you want to be as long as you have a next method, and that next method operates in a certain way. That's enough. The way the next method needs to work in is that it returns an object. And that object really has two values. A value field, which can be of any value. That's the actual value returned by the iterator from the collection. And a done field, which is a Boolean, or more accurately, it's actually a truthy or falsy value, which indicates whether we're done iterating or we still have additional items in the collection. So it's true or truthy if we're at the end of the collection. Otherwise, it's false. So when done is true, value is ignored. That's a really important point. It's not that at the last item in the collection, done equals true. Actually, for the last item, done will still equal false. It's after the last element where done actually becomes true, and then that value is actually irrelevant because we've gone beyond the end of the collection. What that means is JavaScript actually makes life even easier for you. Is as long as done is false, you don't actually have to specify done at all. If it doesn't exist, it's assumed to be false. And once it's true, you don't need to specify the value because it's ignored in any event. So how would you then loop or iterate using an object like that? So we can see here that we're taking a collection. We're using iterator factory to get an iterator from it. Then we've got a loop that seems to loop forever. But as we can see in a minute, we actually break out of it. We use next to get the next item. We look at the done field to see if we're done. And if we're done, there's nothing more to look at. And if done is not true, we call process to do whatever we want to do with the actual value from the collection. And any collection that implements this interface, we can iterate over it using this mechanism. So we can use this type of an approach to implement any type of algorithm over whatever collection we may happen to have. And that's, of course, why I have that roller coaster loop here. So let's look at, again, how I would add this implementation to that linked list example that we saw before. So now, instead of the for each, it actually grew a bit. Instead of for each, I now have iter factory. And as we can see, iter factory returns an object that has just the next method, nothing else. And when we go inside, if current, which is the reference to the current element in the collection that I'm on, if it doesn't reference anything because either the list is empty or we reach the end of the list, then it just returns done, which is true. As we said, when done is true, value is ignored, so it's not needed. Otherwise, it returns the current value and progresses current to reference the next item in the list. So we saw previously how we can use iterators to iterate over collections, but the code that we looked at before was not trivial. It was actually somewhat complicated, lots of boilerplate. We saw the while true, which seems to integrate an infinite loop, and then you had a break later on in the sequence. So it's not easier to read, it's not easier to write, it's not exactly clear what's going on. The way in which ES6 addresses this is by introducing a new instruction called for-of, a new variation of the for instruction called for-of. So for-of is much more usable, and it's intended specifically to be used with iterators. So we have the collection again, but instead of calling iter factory to get a specific iterator instance, we simply iterate directly over the collection using for-of, which as a result is why I use this merry-go-round instead of a roller coaster, just to indicate how much easier it is to use and that it can be used by maybe by small children instead of by adults. The question though is, where is the factory here? Is there a factory here? What actually creates the iterators? And the answer is that there actually is a factory function here creating new iterator instances. It's simply hidden from us. And the way in which it's specified is using something called Symbol.iterator. Now, I'm not going to go into symbols here. They're beyond the scope of this talk. Suffice to say that symbols are a way to specify names for properties on objects in ES6. In such a way, instead of using strings, we can now also use symbols. Symbols in this regard are kind of like strings, but they're built-in unique identifiers. And the bottom line is that if you want to specify a factory, iterator factory for a collection, you do it by assigning a method to the name Symbol.iterator. That's in fact the name of that method. But as you see, other than using the term Symbol.iterator, it looks very much the same as the iter factory that we had before. Turns out that essentially almost all the built-in JavaScript collections in ES6 implement iterator factories in this way. Arrays implement them. Typed arrays also implement them. Even strings implement them. You can actually use it to iterate over the characters in a string. And iterators themselves also implement them, which means that you can use an iterator to create another iterator that iterates over the same thing, and we will see why that is maybe a little bit later on. There are also some new built-in collection types in JavaScript: map, weak map, set, and weak set. Again, I may touch on them a little bit later on, but they also implement iterators and use them, which means that you can use the same type of functionality or loop code to iterate over all these types of collections. Let's modify the previous example to use this type of an iterator factory. This time, I'm actually using the shorthand ES6 notation for defining properties or methods. So instead of using the word function, I simply use the parentheses, but otherwise it's exactly the same thing. So the square bracket Symbol.iterator, that's the iterator factory. And if you look at it, it's essentially the same thing that we had before. I cleaned up the code a little bit, but essentially it's the same. And now we can see how that actually works with for-of. So let's go back to the to the Firefox. And again, go into the console. Let's make it even a little bit bigger. And again, let's create a linked list. Push a couple of items in. And now let's use for-of to actually iterate over this collection. As you can see, we've successfully iterated over all the items in a collection, and undoubtedly this is much easier to read and write than the previous rather lengthy iteration code. By the way, there is a confusion amongst people new to ES6. Some people think for some reason that for_of was meant to iterate over properties instead of keys, whereas for_in iterates over keys. That's not the case. For_of is specifically intended for looping over iterators and will only work if the object that we provide actually has an iterator factory method associated with Symbol.iterator. If we try to pass something that doesn't, for example, I'll just pass an empty object, we will see that it fails. And it fails precisely because Symbol.iterator is not a function. So we saw how, thanks to for_of, the code for looping or enumerating iterators is much simpler than it would otherwise have been. But creating iterators is still much more lengthy than it should be, maybe, and certainly involves a lot of boilerplate code. And if we are doing something that's more of a complex type of iteration, let's say instead of a linked list, we have some sort of a tree, and then you need to go up and down the tree and remember where you were and maybe make various decisions, then the code in the iterator can become much more complex and much more difficult to follow and to debug. As a way to address this problem, ES6 introduces the concept of generators. Generators are kind of like functions. You can think about them as a special kind of functions. You actually use the function keyword when you create a new generator, but instead of just the word function, you actually put function star. And that specifies that gen in this case is not a regular JavaScript function, rather it's a generator. And as we will see in a minute, using generators to create iterators, to loop over collections, is much, much easier than writing the code manually by hand. And as an example of this, let's look at a quick demo, again using that linked list example. So switching over again to the development environment, let's switch to another file. Here we can see that, again, thanks to the ES6 syntax, we don't actually need to put the word function. All we need to do is prefix it with a star. Now it understands it's actually a generator. And as we can see, the code indeed has become much, much shorter. Compare this again to the code that we had before, which was this. As you can see here, we have something like, I don't know, what is it, 15 lines. And here we have all of 3 lines, and that's including the closing brackets. If we look at this code, we see that the generator iterates over the collection in a very trivial kind of a way. We basically just loop over it as if just a regular loop. And so the question then becomes, how do we push the values out of the generator? And here's the unique thing. It's done via the new yield statement in ES6. So a couple of things about generators. First of all, they create the next method implicitly. As you can see in this example, I don't specify anywhere that I'm returning an object having a next method. The generator creates this implicitly. In addition, I'm not creating the return objects with the value and the done. Again, they're created implicitly. I'm just providing the value. Done is created automatically for me. The yield statement, that's where it really becomes interesting. Because up to now in JavaScript in general, we've been used to the fact that when you call a function, the function has an entry point. It executes until it either reaches the end or encounters a return statement, and then it goes out, and then it's done. So you call into a function, the function does whatever it does, exits with a return value or not, and then it's done. Yield changes the rules of the game. With yield, the function is actually able to provide a value without actually finishing. The consumer of the function's value, the function's client, gets that value, does with it whatever it wants, and then hands over control back to that function from where it was, not from the entry point, from where it was, and to resume performing whatever calculation it has until it again reaches a yield instruction. So again, if we go back to the example, we'll see that this is precisely how it works. So it starts looping over the collection, over the elements in the linked list, reaches the first one, yields it, it gets handed off to the for-of loop, and then when for-of needs another value, instead of starting again from the beginning of the function, it resumes right after that yield with all the variables and all the context that I had before. So it's like it's jumping back and forth between two pieces of code in JavaScript, not the sequential type of instruction execution that we're used to. Now, it's important to understand this is not threading. This is not two things executing in parallel. It's just switching over the context of the execution back and forth. So again, as I said before, when the loop is finished, in this case, when I exit the for and the generator finishes, it automatically creates the return value where done is true and the for-of loop finishes. It can be kind of tricky to think about it, so what I would recommend for you to do is to actually load this example. As I said, all these examples are available for you to play with afterwards. Put breakpoints in the generator. For example, you might want to put a breakpoint, let's say, here, and put a breakpoint in your for-of loop and see how it hands over and executes one after the other. And you can look at the call stack and see how the browser actually, or the environment actually manages that. It's a very interesting exercise to do. So we've seen a generator method implemented inside an object or on top of a collection. But sometimes it actually makes sense to implement a generator not as a method or a property of an existing object, but rather as a standalone function. I call them free generators. So a free generator could be useful, for example. Why would you want a generator not on top of a collection? Why would you want a generator just as its own function? Well, because generators can sometimes be useful as a means to automatically, dynamically generate a sequence of values. That can be worthwhile, for example, when computation is cheaper than storage. So instead of storing all the values, I can just compute them on the fly whenever I need them. Or alternatively, I can use that when the sequence is actually infinite, and obviously I can't store an infinite sequence in memory. Finally, I can do something called lazy evaluation. Sometimes it doesn't make sense to compute all the values in advance. Instead, I'll just compute the values when I need them, if I need them. So generator, and in addition to that, generator functions can receive arguments which can influence the way in which they work. Let's look in an example of this, and it's actually a fairly famous example. How many of you are familiar with the Fibonacci sequence? So the Fibonacci sequence is actually a very famous sequence of numbers. Basically, every number in the sequence is the sum of the true preceding values. So it would be, let's say, 0. Sometimes people start with 0, 1. Sometimes they start with 1, 1. In this case, I start with the 0, 1. So it would be 0, 1, 1, 2, 3, 5, so forth. Now, that sequence obviously is infinite. It goes on forever. But in this case, using iterators and generators, I can actually look at this sequence and use that sequence as if it were an infinite collection, precisely because I'm generating the values on the fly. Now, if I were to just iterate till the end of the sequence, I would be stuck in an infinite loop because the sequence does not, in fact, have an end. So as I said, you can actually pass arguments to the generator. And in this case, I pass an argument which specifies how far I want to go. In this case, not in terms of the number of items, but rather in terms of the size of the item. And I specify the default value as infinity, which basically means that unless I specify some other value, I will indeed go on forever. Now, here's some interesting ES6 syntax. I'm actually initializing prev to be 0 and current to be 1. This is called destructuring, again, kind of beyond the scope of the session. I then loop as long as current is less than the limit that I'm passing in as an argument. I'm specifying prev to be the existing current, and current to be the sum of prev and current. So every time current is the new value in the sequence, which I yield. Let's see how I would use this as a quote-unquote infinite collection. So again, going over to Firefox, I would do something like that, like this. I would do for, let's say, let I of Fibonacci, I did it with a small f. Fibonacci, let's say, until the value of all the values less than, let's say, 30. And here are all the values. So as you can see, I've actually used the same kind of syntax that I would use over a collection, instead of over a collection, on top of a sequence that gets computed in real time every time that I actually invoke Fibonacci. I can actually maybe think, if Fibonacci were a little bit more expensive to compute, I might do like a trick of computing the value the first time and then storing it for later reference, for later reuse in order to reduce the cost, but that's just an optimization. And in terms of the consumer, it would look exactly the same. Now, we've seen for of as a means of iterating over values using an iterator, but it turns out that there are additional ways, and some of them which are actually might be nicer in certain contexts, and one of them is the spread operator. So a spread operator actually expands any iteratable object in place into a variety of destinations. For example, into an array. So if, for example, I wanted to get an array of these values of Fibonacci, instead of using for of to assign them into an array, I can simply do something like this. And here I get an array of all these values that I saw before. So that's a really cool way of copying values into an array from any type of a collection. And if you recall, we actually said that arrays themselves also implement the iterator interface, which means I can use this mechanism to copy arrays into other arrays, which kind of makes operations like concat kind of not really that important anymore. So if I wanted to concat two arrays, I can use this instead. So I could write something like this. And here I've combined two arrays into a single array, and it uses the exact same syntax, again, because both arrays actually support or implement the iterator interface. Another similar example is, instead of putting it into an array, I can put it into arguments. Works exactly the same way. I can also use it for destructuring to assign values into other variables. Just play with it and see how it works. But that's one of the things that I really like about both iterators and generators, is that they really play nice with other features and capabilities of JavaScript and ES6. There are various advanced topics having to do with it. I'm not really going to delve into them. It goes, again, beyond the scope of this session. We just don't have the time. I mentioned map and set as new collection types, and just the fact that they support the iterator and generator interfaces means that you can use them like you would use an array or whatever. In addition to next, there's also iter throw and iter return as a way to signal errors or to terminate loops immediately. I'll not go into that. There's yield star for yielding an entire sequence of values instead of just one value. Again, I won't go into that. I will touch on that final step, and that is the fact that you can in fact use yield as a means for two-way data flow. So we've seen how yield pushes a value out of the generator into the loop, but it can also receive a value back and push it back into the generator to be used for the computation of the next value. And let's look at a very simple example of how something like that would work. So I've implemented a very simple accumulator that basically adds values together. And as you can see, it uses yield, but it actually doesn't just emit a value using yield, it also receives a value using yield, which means that when I push out a value, I also get, as a sort of a return value, an item that I use for the next iteration computation. Now, how do I push a value in? Very simply, I pass it as an argument to the call to next. So let's see how something like that might work. It basically works something like this. Let's initiate accumulator with just with 0, and then I can do a.next. The initial value is 0, as we can see returned in the value. But now, if I push in 1 again, I get 1, because 0 plus 1 is 1. If I now push in, let's say, 4, I get a return value of 5. So I'm actually able to use next and yield not just as a one-way communication flow from the yield to the next, but also as a means to push data back from the next into the yield. Now, it turns out that this can actually be very, very useful for implementing sophisticated logic in which we write code that performs asynchronous operations but looks as if it's synchronous. Now, I won't go into details, but I have an example here that I encourage you to play with after this session, where I basically use this mechanism to download data, but the whole entire download operation, which of course in JavaScript is asynchronous, looks as if it's synchronous. So here we can see that my main code is actually the generator. So I've kind of reversed the situation. Instead of consuming values from a generator, I'm using the main as my generator. And I'm downloading one file, getting its return value, and then I download another file and gets its return value or content. So the code looks synchronous. You know, if we're used from JavaScript to code in which we do all sort of things with promises or callbacks, you don't see that here. It looks really synchronous, but in fact, it is a synchronous code. And again, as I said, I encourage you to play with it. It simply just works. So to summarize everything that we've talked about today, so the value of iterators is as a means to abstract collection implementations so that we can use either our own collections or built-in collections exactly the same way. And as a result, we increase code reuse because we can use existing algorithms or algorithms that we develop on top of whatever collection we happen to have. It levels the playing field between built-in types like arrays and types that we define, what are called user-defined types, like the linked list that I've shown before. And as we saw with the spread operator and with for-off, it really integrates well with a lot of built-in ES6 features, like the spread operator, like the structuring, etc. And finally, as I kind of hinted to in the last example, it makes it possible to write sync-looking asynchronous code. As I've said before, you can find the presentation here at this link, and you can also find all the demos that I've shown on GitHub. I do encourage you to play with them. That concludes this talk. Thank you very much.